Hey everyone, thanks for tuning into the Dynamo Office Hours. If you're new to the stream, we are going to be hosting roughly an hour session to talk about today disaggregated inference and do a live Q&A at the end. If you're returning back, appreciate you tuning in again. We have a much better production setup than we did last time. We're tuning in from NVIDIA Endeavor, which is one of our two offices here in Santa Clara at NVIDIA HQ. My name is Anish, and I'm a product person on the Dynamo team.
And I'm Neil. I'm a technical marketing engineer also on the Dynamo team.
And today we're going to be talking about disaggregated serving, why it's important for LLM inference, and how Dynamo actually helps you serve disaggregated inference at data center scale. Neil, you want to kick it off?
Yeah, absolutely. So, one of the things that we really, built Dynamo for was to help people perform disaggregated inference for large language models in order to really get the best performance, the best performance possible with their hardware. But we want to talk a little bit more about, what is disaggregated inference? Why is it useful? What are some of the performance characteristics of, the different phases of LLM serving and sort of how that plays into to disaggregated inference.
So if you tuned in last time, you probably remember the Q&A format that I had where I'd always give these questions that seem relevant. And so today I want to kick it off with Neil as he kind of brings up the presentation. What does normal inference look like? And why do we even have to do disaggregated serving in the first place?
Yeah, so normal LLM inference basically involves sort of two stages. There's a prefill phase and a decode phase. And without disaggregated serving, if we leave that to the side for a moment, that all happens on the same GPU. So basically you have, one GPU that's executing the sort of initial phase of the LLM execution. And then that same GPU executes the second phase of the LLM execution. And that can cause some issues, which we'll talk about sort of later on in this presentation. But a really important topic and something that comes into play a lot when you're talking about large language model inference is the KV cache. And basically the idea with the KV cache is that because large language model inference is sort of this iterative process where, the model itself is kind of outputting a single token at a time, and you have to like re-execute, basically like you feed the output of the model back into the model in order to get the next token. There's basically you can like save part of those intermediate computations in order so that you don't have to recalculate them when you're sort of iteratively executing the model. And so that's what we call the KV cache. And there are a ton of different things, a ton of different performance implications for the KV cache, which, Dynamo can really help you optimize in order to get the best performance out of your large language model. Yeah. So, and here, again, we're talking about those sort of two phases of inference. So there's the prefill phase, which also sometimes here called the context phase, and then the decode phase, which also, again, sometimes here called the generation phase or the sampling phase. And if you ever used a large language model, like ChatGPT or something like that, you'll sort of be sort of like implicitly familiar with what's going on here. So the prefill phase is, the information that you feed into the large language model, kind of you might ask it a question, you might be doing like RAG and have some context that you include that you've retrieved, and that's all the stuff that sort of you as the user are putting into the large language model. And then the decode phase, the generation phase, is basically what the large language model is spitting back out to you. And these two, like mathematically, there's kind of like the same thing going on. That it's all being fed into the same model, but underneath, like behind the scenes, under the hood, there's actually like very different computational patterns for these two different phases of large language model inference.
And so when you're running these two phases on the same GPU, aka co-located serving, you're actually kind of balancing tensions between two different things. First tension that you're dealing with is like low first token latency, which is the time it takes for the first token itself to come out, and actually like inter token latency itself, so in between tokens themselves. And this is essentially the tension between sort of the necessary computational resources necessary for prefill versus what's needed for decode, right? And so you're kind of dealing with these two tensions when you are serving this on a single co-located GPU, and this is why the concept of disaggregated serving even came up in the first place.
Yeah. I'm just skip past that. So, and in particular, the difference between the prefill phase and the decode phase is that the prefill phase is very, very computationally intensive, whereas the decode phase is much more memory and memory bandwidth intensive. And the reason for this has to do with the ways that you can batch sort of multiple parts of the inference together differently during the prefill phase and the decode phase. So during the prefill phase, because the model sort of has all of the tokens, all of the information, up front that you've given it, it's able to kind of process, all of those tokens in the sort of input at the same time in parallel, which means that you really get to take advantage of like the kind of amazing parallel processing power of GPUs. But during the decode phase, because you only get one token out at a time and you have to sort of feed that back into the model to get the next token, you can't actually process multiple tokens for the same request at the same time in parallel. And so what that means is that, there's still some things that you can do to batch like multiple requests together. You can play around with things like speculative decoding in order to improve your latency by doing multiple things in parallel. But at its core, it's a much more memory intensive and less compute intensive process, the decode part of the inference as opposed to the prefill part. So let's talk a little bit about how we actually perform disaggregated inference and kind of solve some of those issues that we talked about where the prefill and the decode have very different compute patterns. So what I've got here is a diagram that kind of illustrates some of the ways that you can kind of pull apart the prefill and the decode part of the model inference. And so what we're showing here is that we have basically dedicated instances of the model performing prefill, and then a single dedicated instance of the model that is performing the generation. And what we do in between is we actually have to transfer that KV cache from the dedicated prefill nodes to the dedicated generation node. And that's that KV cache that sort of saves you from having to do a bunch of recomputation as you sort of generate more and more tokens out of your large language model.
But this doesn't work for every single inference scenario, right? Like, just because I can put something into prefill and decode, that doesn't always mean I need to do disaggregated serving, right? Can you talk to me a little bit about why we might have scenarios where this disaggregated serving makes sense, but where it actually might not make sense to have disaggregated serving?
Yeah, definitely. So one of the biggest benefits, there's really two sort of main benefits that we see with disaggregated serving. One is, what we talked about where, you have these like two different computational patterns. So if you're trying to do both at the same time, they can sort of conflict with each other where you're trying to do, these prefill computations and these generation computations. You can't do them both at the same time. So you're kind of like thrashing back and forth, between one and the other. And then the other thing, which is also sort of illustrated here in this slide, is that you can actually use different forms of parallelism for the prefill phase and the decode phase. And what that sort of means is that, with these large language models, there's a lot of different ways to kind of split them up across multiple GPUs, or maybe you have multiple replicas, in order to facilitate like higher throughput. And because of those different computational patterns for the two phases, you actually get, different benefits for having different kinds of parallelism for the different phases. So here, for example, what we're showing is that there are sort of three replicas that are all performing prefill, and there's only one that's performing generation. And that's because, again, with the prefill, it's performing like a single request, but it's like performing all parts of that request in parallel. Whereas with the generation side, you have to actually like batch multiple requests together in order to kind of get like the highest utilization of your GPU. And so you get some different benefits for having different kinds of different numbers of replicas for that prefill phase and that generation phase. There is a downside. You do have to handle that kind of transfer of the KV cache from the prefill nodes to the generation nodes, and that can add some overhead. And so that's sometimes why you see disaggregated serving actually not providing benefits for certain use cases. And that's what we've done with Dynamo is integrated this library called Nixel, which really helps to improve that sort of direct GPU to GPU communication for the KV cache. And so you're really getting, you get very good performance for that KV cache transfer, but there is still some overhead. So it's not always the best choice.
Yeah. In general, when you are thinking about like how to determine the optimal serving strategy, you want to think about a couple key characteristics, right? You want to think about the actual serving mode itself. Is it going to be running on the same GPU, or do you want it to actually run disaggregated in this format that Neil is talking? On top of that, you have to really kind of handle sort of the inference traffic and expect what you are going to be facing, right? So some things like that include like ISL, or input sequence length, right? Like how long is the input actually going to be? And how large do you think the output is expected to be? OSL, the output sequence length, right? And in between that, it's also how many queries per second do you expect to handle, right? And these are kind of common terms. QPS is a very common term in a distributed system for how much load you expect your system to actually take. On top of that, when it comes to GPUs, you also need to take into account your target hardware, right? So are you serving on A100s, H100s, the new Blackwell generation GPUs? They have their own characteristics and different hierarchies, memory differences, right? There's also the sort of interconnect, whether it's like SXM, NVL, PCIe. Those really you got to be taken into account when actually deciding your serving strategy.
Yeah.
And finally, also there's a ton of latency constraints, right? And so if latency is a big deal for you, as in the first token latency, as I mentioned previously, that also kind of comes to the picture when trying to determine what is the right optimal serving strategy, but also the partitioning strategy and the parallelism strategy that Neil was mentioning.
Yeah, and actually, I like that you brought up the sort of heterogeneous, compute, having different kinds of GPUs. One of the really cool things with Dynamo is that you can actually have different kinds of GPUs, executing the different parts of the disaggregated serving. So you could have, a different type of GPU that's like more suited for prefill, just doing prefill, and then another kind of GPU that's better suited, maybe has higher memory bandwidth or something that is just doing the generation phase. So you really can optimize your hardware like for the very specific parts of the large language model inference to get like really good utilization of your GPUs, and that's something that I think is super neat, right? Like it's you can have these like heterogeneous clusters and really take advantage of them. So
yeah, that's one of the hallmarks of Dynamo for sure when we designed this and this is architected. So Neil, I think it makes sense to kind of show what this looks like in practice, right? You want to bring up an example of disaggregated serving running?
Yeah, absolutely. Let me pop over and share my screen. Okay, so I've got my terminal up here. Can we, are we, yeah. We're good. Okay, cool. Yeah. So I've got my terminal up here, and I'm going to show how we actually like perform the disaggregated inference. And what we're going to do is I have a node that has a bunch of GPUs on it. I'm going to dedicate one of those GPUs to perform the prefill part of execution. I'm going to dedicate one of those GPUs to perform the decode part, and then I'm also going to spin up a HTTP server to actually receive the requests, and then I'm going to send requests to that server, and it's going to pass through all of those different components. And this is all using different components within kind of a single Dynamo deployment.
Yep. Let's do it.
All right, cool. So the first thing I'm going to do, and I have some this little shell script here that kind of has the example commands. The first thing I'm going to do is run this prefill worker. And so I'm using SGLang to actually do the execution. Dynamo supports a lot of different execution backends, SGLang, VLLM, TensorRT-LLM, Llama CPP, a couple of, a bunch of different stuff. But here we're just going to be using SGLang. And what we're doing is we're executing this. Let me zoom in a little too, just make it a little bigger. What we've got here is this SGLang worker module that's like part of the Dynamo package, and we're pointing it at the model that we want to run. And we're also, TP1, so that's indicating that's just going to run on a single GPU. This disaggregation mode prefill, so that's letting SGLang know that it's just going to do the prefill part of the model execution, and then this disaggregation transfer backend Nixel is letting SGLang know that, okay, once you're done doing the prefill, instead of continuing on, you're going to send all those computations, that KV cache that you've created, off to somewhere else using the Nixel transfer backend. So let me pop that in and run that in my terminal. And then as that sort of spins up, we've got a similar thing going on here with our decode worker. So again, I've specified CUDA visible device 1 to sort of let it know instead of running on the 0th GPU, it's going to run on the 1 GPU, the second GPU. And then the rest of the command is pretty similar, but you'll notice a couple of key differences. So here I'm running sglang.decode worker. So it's like a slightly different part of the slightly different sort of component within the Dynamo package. And then again, I've also indicated here disaggregation mode decode. So again, that's just letting us know that, okay, this particular component that I'm launching is just going to do the decode part. It's going to sort of wait for something to come in over Nixel. And then it's going to, do the decode based on that instead of actually receiving a full request. So let me pop that bad boy into here. And then the final sort of Dynamo component that I'm going to run is the front end. And so what I've got here is this Dynamo run command. There are other ways that you could also launch a sort of API server. But what this is doing is, this in is saying, okay, it's going to take in requests over HTTP. So, sort of like a standard kind of like REST API. In this case, it's going to look exactly like an OpenAI compatible API. And then out Dyn is basically saying, okay, you're going to pull in that request from HTTP and you're going to spit it out into Dynamo. And it's basically going to figure out, okay, where does it actually need to go once it's kind of like in that Dynamo, namespace, and how is that, forwarded to the sglang workers that we had running. So let me pop this into here. Okay. Oh, always fun. Let me change the port. Let's do 8080. All right, cool. Yeah, and so we can see that it just sort of discovered that I'm running this DeepSeek model. And basically what it's doing is it's sort of like checking the component registry within Dynamo and seeing like, okay, you've launched this model somewhere. So I know how to take in requests and forward them into Dynamo. And let's just check and see if these guys are ready. Yep, request handler initialized, decode request handler initialized. So those are sort of ready to take in requests. And now let me actually send something. So I've got this curl command somewhere. I got to change the URL. And so this, again, just looks just like a, OpenAI style curl command where I'm specifying the model, that same sort of DeepSeek distilled model. And then I've got my messages, stream set on false. And I've got this sort of JQ command to kind of clean up the output so it's a little bit easier to read. And let me submit that. Let's minimize this part. Okay, and if we go back and sort of look at our running prefill and decode servers, you can see that it's got this prefill batch and it's received a sequence, doing some calculations there, and this decode batch as well that's running there and doing some calculations. You can see the throughput, the number of tokens per second. You can see the input throughput here. It's a little buggy. That should not be 0, I think, but yeah. And we can see if I come back to this terminal, our output. So I requested, what did I request? I requested a story about a cowardly cat. And we've got a very long story about a cowardly cat here. Yeah, that's pretty much all there is to it. So basically, just to give like a little bit of an explanation of what's going on under the hood, if you want to learn more about the kind of the architecture and like the way that requests flow through the system, definitely check out the documentation. But basically what's happening is that, that front end discovered that we had the prefill worker running and sort of listening for requests to come in. And the way that it discovered that is by looking at the component registry, which is in etcd in Dynamo. And then it's listening on that port for incoming HTTP requests. Once the HTTP request came in to the front end, did that sort of, tokenization, and then it sent it off to the prefill worker. The prefill worker did the prefill part of the execution, and then it took that KV cache and sent it over to the decode worker. The decode worker took in that KV cache, started generating the output tokens, and then streaming them back through the front end so that the client could receive all of those tokens. Well, in this case, we didn't do streaming, so it just sent them all in a single chunk. And then the client, takes that response and prints it out onto the screen. So that's sort of a basic look at how we can do disaggregated serving with Dynamo. Obviously I was just running this in like a bunch of different terminals in in my command line. You could also deploy this with Kubernetes, and we have some examples of different YAML files that you can use to deploy it. You can use like Docker Compose. There's all sorts of different ways that you could deploy it that are potentially more convenient than just like running a bunch of bash commands and scripts and things like that. We do also have a bash script that just runs everything in a single terminal as well.
Yeah. So Neil, I have a question. So when you set this example up, obviously there's a super simple example to explain how prefill, decode, disaggregated serving works. But it's not always going to be a 1-to-1 ratio between prefill and decode workers, right? Can you explain a little bit more what that means?
Yeah, definitely. And so in that, if you think back to that diagram that we showed, where there were sort of 3 different prefill workers, then a single decode worker, that's something that you can do with Dynamo, where you have different ratios of the number of prefill workers and the number of decode workers. And Dynamo sort of figures out, how to route requests and how to route requests across all of those different those different workers. You can also, use different kinds of parallelism for the different phases for the prefill workers and the decode workers. And Nixel kind of figures out how to like transfer the KV cache, because there's some complications where like, oh, like if I've got the KV cache split across 2 GPUs in prefill, but then it has to be on 1 GPU in decode, like how do I figure out which bits go where? And so Nixel handles all of that. And really what you end up with is having this like really enormously flexible system with Dynamo, where you can have totally different setups for the prefill and for the decode, different numbers of GPUs, different numbers of replicas, different kinds of parallelism, and it all just kind of works seamlessly together. So something that's super cool with Dynamo.
Yeah, something really cool we're working on internally that we're looking to share very soon is a way for you to actually just input sort of some of these metrics that you're looking for your application, and how you can actually determine what the optimal prefill decode ratio looks like and the sort of parallelism that you should be using across it, right? And so, like I said, it kind of comes back to a couple of characteristics. What GPUs are you running on? What model are you using? Is it going to be DeepSeek R1, which is more of a mixture of express model, or is it something like Llama 405B, which is more of a dense model, right? There's a couple other considerations, right? Are you going to have super long inputs going in, like massive documents or massive conversations? Is it going to be short outputs or long outputs, right? And so we're working on a tool that can hopefully help help you determine what the initial PED ratio should be. And then over time, the whole goal of Dynamo is once you actually launch the system out, you should be able to intelligently scale your prefill and decode workers up based on the requests coming in or the lack thereof, right? And so I think that's something really cool that we definitely want to be sharing in the coming weeks. And so definitely we'll keep an eye out for that one. All
right. Fantastic. Let me stop sharing. And I see we've got a couple of questions in the chat. Let's check some of these out. Okay, here's one. Currently building a hybrid RAG system, vector and graph RAG, and interested to know how Dynamo and KV caching might fit in. Can you containerize as part of an MCP server, 1 GPU style? Okay, there's a couple of things in here. So I guess like first off, Dynamo is really great for RAG systems, especially because like with RAG systems, you tend to have really large input sequences because you're like retrieving a bunch of data to feed to the model. And then on top of that, if you're having sort of like a back and forth conversation with the RAG system, or if you have like multiple requests that can like share different documents and things like that, the KV caching can really improve your response times. And in particular, when I'm saying KV caching, I mean KV cache reuse, right? So like imagine that you have a set of like 5 documents and you have a bunch of different questions about those 5 documents. One thing that you can do is like send 5 separate requests that each request has that set of 5 documents and then your question. If you weren't using KV cache reuse, basically what would have to happen is that your model would like do the prefill on all of those documents and your question every single time you submitted a request. And there's like basically just like a bunch of redundant compute. With Dynamo and sort of other kinds of like KV cache reuse systems, what it does is it kind of like it saves that KV cache of those like initial documents that you input as your request and reuses those for future requests. So that's something that is like really improve the execution time of your system.
Exactly. And you can think of the flow as like when a request comes in, as you have this RAG system, right, it's going to first hit the decode worker and just see if there is any KV cache available. If there isn't, it's going to go to the prefill worker to actually generate and take in this context and then generate these key values. That's going to go back to the decode worker. But if there is already a prefix hit that's done by the decode worker, it'll just use that KV cache and just compute the answer much more faster. So you're not having to recompute and deal with any inefficient computation in your system.
Yeah, there's also this second part here. Can you containerize as part of an MCP server? I think this is another really interesting question. We've been thinking about different ways that we could incorporate MCP with Dynamo, you know, to be able to like have like tools running within the Dynamo system and be able to cache things and things like that. We don't have like perfect answers for you quite yet, but there's definitely something that we're exploring. We have a bunch of really cool ideas that you might see in the future about like ways that you can do tool calling and stuff in a more efficient manner using Dynamo.
Yeah, we don't have any initial or immediate support for MCP on our roadmap, but this is a really good first issue, or hopefully something the community could help contribute back. So if you have any ideas on this, definitely feel free to hit us up on Discord, make a GitHub issue, find some way to like share your ideas that you might have around this, so we can come help collaborate with you and see how we can get this sort of support in.
Yeah, definitely. We always want to hear sort of what our users are using Dynamo for, or what they would like to use Dynamo for. What kind of new features could be incorporated. So yeah, definitely check out the Discord and ask us all the questions that you'd like. Okay, I see any support for SM120 yet? Which one is 120? I think it's Blackwell, right? Or is that?
I don't know off the top of my head, to be honest.
Yeah.
Assuming it is Blackwell, yes, we have support for Blackwell. Yep.
Yeah. There you go. All right. If it's not Blackwell, if it's like a future thing, then it's not something we can talk about.
Yeah, we have some other engineers in the team that could probably answer this to greater detail. So again, hit us up on Discord and just feel free to at me on the Discord, and I can make sure your question gets answered.
Yep. Okay, another great question. Should Dynamo be considered like a middleware API that connects LLM models with each front-end request and serves API response? Yeah, so Dynamo really is like a kind of modular system that has a bunch of different components. And so one of those components is that sort of, that middleware, that router that like takes in requests and sends them to the workers. But it also does have a bunch of other stuff within it. So things like Nixel that help with that, that transfer of like large KV caches and large amounts of data, has things like discovery and being able to, like Anish was talking about, that sort of planner that helps you spin up different numbers of replicas for the different parts of the execution. So that's definitely one part and sort of a very significant part of Dynamo, but Dynamo also has some other stuff associated with it as well.
Yeah, and that's why we designed Dynamo to be modular, right? If all you need out of Dynamo is a router that can route requests to the right, models, just take the Dynamo router and take it out and go embed that in your system, right? If you want some of the other pieces that we offer too, you can also use that. And that's kind of the benefit of like actually using Dynamo in itself. And that's why we've designed it very thoroughly to be something that is modular and more a la carte if you want to use that for your use case.
Got it. Okay. They clarified. Our SM120 is Blackwell, the RTX 6000.
Okay.
Yeah, great point. So Dynamo itself, as this sort of like modular components, is like it doesn't actually like require like having the GPU. The part that the like GPU compatibility depends on is the actual LLM inference engine. So like in the example that I showed, we had SGLang, there's also TensorRT LLM, VLLM, and others. And so it's really down to those to support particular GPU models.
Yeah.
That being said, TensorRT LLM definitely supports Blackwell GPUs. The other frameworks, there's various levels of support, so it kind of depends on exactly what you're trying to do. But yes, in general, it is supported.
Yeah, something we're trying to make more clear that I'm making sure we add to the README right now actually is like a matrix that helps help you understand what features are available and whether this actually runs on Grace Blackwell, or the RTX Pro 6000. So in our upcoming release, which is August 6th, we hopefully should have this matrix coming out. But in the meantime, if you're an avid, enjoyer, enthusiast of Dynamo, you'll probably see us put that change in the README very, very soon.
Yeah, real Dynamo enjoyers. All right. Is there any connection or interaction between NVIDIA Dynamo and NVIDIA Triton and TensorRT LLM, or is NVIDIA Dynamo a separate system? you want to take a stab at this one?
Yeah, this is a great question, actually. And you can think of Dynamo itself as an evolution of Triton and TensorRT LLM, right? And so at its core, Dynamo is still using these inference engines the same way. So we're also still using TRT LLM underneath the hood, if that's what you want to use. But Triton was kind of following this monolithic inference model from previous generations of deep learning. And once LLM inference kind of came around with this neat little prefill decode and disaggregated serving kind of became a concept to optimize inference, Dynamo became almost an evolution of Triton for this new age of deep learning inference. And so we're really excited to see Dynamo as the future of Triton. But of course, Triton still has a ton of really, really cool use cases in the deep learning community. And so we're working really hard to make sure pieces of Dynamo are really modular and can be used in Triton workloads, right? So for example, router, which can intelligently route requests. For example, Planner, which can actually monitor a system and scale up replicas. Various other different components, like maybe even Nixel, can be used as well. So there's different pieces of Dynamo that you can adapt to your Triton workload if that's what you are using. But we really see Dynamo as the evolution of Triton as we go into this new age of LLM and just deep learning inference in general.
Yeah, and TensorRT LLM also, as we talked about, Dynamo has a lot of different execution backends. TensorRT LLM is one of those execution backends, and yeah, we have great support for TensorRT LLM. It's very fast.
Yeah.
So we love TensorRT LLM. Yeah, it's really well supported in Dynamo. Okay. Will Triton Inference Server be deprecated in the future with Dynamo replacing it? We don't have any plans to deprecate Triton at the moment. There's like Anish said, there's a ton of use cases that Triton is still really great for that aren't necessarily good fits for Dynamo in sort of the way that Dynamo works, at least at the moment. And so yeah, Triton's going to be around. What we're really looking to do, our sort of current idea is to take components of Dynamo and actually bring them back into Triton so that Triton gets some of that goodness from the Dynamo development.
Yeah, Neil nailed it.
Yeah. All right. Cool. I think I'm not seeing any other questions. So do you just want to chat? You got any other questions?
Let's see. What questions could we kind of cover today? So I know we talked a lot about, did we show this one prefill, one decode worker example, right? Somebody in the chat asked about the RAG application. Mm-hmm. I'm curious, like if I'm a builder of an AI application, like what AI applications really fit well with disaggregated serving, right? The sort of high ISL, low OSL use case that we talked about.
Yeah. RAG is definitely like a really great use case. The sort of in like a good rule of thumb is that the higher your ratio of input sequence to output sequence, the better disaggregation is going to be for you. And this sort of goes back to that idea of, being able to have like different, different parallelisms, different numbers of replicas, and the different compute patterns of decode and of prefill and decode. When you have a really long input sequence length, you really want to have like dedicated GPUs to just do the prefill portion, because if you have like a really long input, like if you're spending a bunch of time on prefill, then you get to, and you're trying to do everything on the same GPU, you don't get to spend as much time on the decode. And so like you end up having to, wait a really long time to get those, to get the responses from the decode sort of part of the decode part of the inference. And so it's like really beneficial when you have super high input sequence lengths to disaggregate things. That's not to say that you don't get any benefits if you don't have a high input to output sequence length ratio, but that's where you get sort of the most benefits.
Yeah, that makes sense. And I know the focus was on disaggregated serving in general, but like just take a step back. Why would I, as a new user, want to use Dynamo in the first place? Is it just disaggregated serving? Like, there's got to be more than that, right? Yeah.
There's loads more. There's loads more than disaggregated serving. Today we focused a lot on disaggregated serving because we think it's a really important topic, and we think it's a way that you can get really great performance. But Dynamo has a bunch of other components. So a lot of it is based around KV cache and the different ways that you can handle the KV cache. KV cache reuse is a great example. We talked a little bit about it in the sort of the RAG question, where you can kind of share computations across multiple different requests and sort of, not have to do redundant computations. It's like a very traditional form of caching, right? Where, like between different requests, if you have like similar inputs, you avoid having to recompute the outputs.
Yeah.
Another thing that we have coming is sort of KV cache offloading in a similar vein. So being able to like, if you want to like really take advantage of KV cache reuse, these KV caches can get really, really large. And if you just want to store them all in GPU memory, you can like very quickly like overload your GPU memory. And so you have to have some really intelligent ways of like, offloading that KV cache store onto either host memory or into storage or like into like, like a remote object store, like, this whole sort of hierarchy of memory to be able to like really take advantage of, reusing, like storing as much as possible for later reuse.
Yeah, and I imagine that opens up a ton of use cases, especially when you start offloading the KV cache, right? But there was one piece that you touched on. And I know the focus of today was disaggregated serving, but KV cache reuse is actually a really, really important feature of Dynamo. Right?
Definitely.
And so I guess we talked about the disaggregated serving use cases that make sense. What are some use cases where KV cache reuse might make a lot of sense?
Yeah. So I think the two sort of big use cases that come to mind for me are, again, RAG sort of kind of runs through all of this, but where you have, various different requests that are like reusing the same context. So that like are asking questions about the same documents and things like that. And then the other use case is kind of when you have back and forth conversations or sort of, like multi-turn kind of requests and responses, usually in the form of like a chat with a large language model. And the idea here basically is that, after the model has generated an output, it's already like, it's got that, sort of KV already generated because it needed to create it. You needed to do all those intermediate computations to generate the output. So if you're going to ask another question, sorry, I just saw this question. If you're gonna ask another question to the LLM, you're able to hold on to the KV cache from when it generated that response and use it again for the next question.
Yeah, that makes sense. Something I'll add here as a use case is also, whenever you are trying to make an LLM follow instructions really well, you try to input these really long system prompts to make sure it follows instructions. Oftentimes, you don't want to waste computation, right? Constantly just churning through this really long system prompt and inputting all these tokens in your prefill phase. So again, KV cache reuse really helps a lot there. So you can just speed up the time first token as well as the inner token latency, right?
Yeah, and talking about that, another feature that I don't think we've had a chance to mention today is this KV aware routing, which is another big part of Dynamo. When you have this KV cache offloading, normally when you're like doing like large language model inference, all of the different instances, the different replicas are kind of identical, right? They're stateless in a certain sense. When you start thinking about KV cache offloading and like actually like holding state between requests, you have to start thinking a little bit more deeply about how you route requests to the right worker in order to take the best advantage of whatever KV cache has been generated previously. And so within Dynamo, we've got a special like smart KV aware router that does exactly that. That basically takes a look at the incoming requests, checks to see if there is a particular worker that is like best suited for responding to that request, and sends that request over there to that worker. And so that's another thing, where if you're serving like a lot of users and you have a lot of sort of back and forth conversations, then that's something that you can really take great advantage of. All right. So before we go, we've got we got a special guest. If he wants to come by and say hello.
Hey everyone. Kyle, if anyone knows who I am, I'm one of the architects and an engineering leader in Dynamo. I just wanted to come say hi and see if we had any interesting questions and hang out with Anish and Neil.
Yeah, I mean, I think we had one sort of really like overall question, which I think would be great for you. Is like, when should somebody think about using Dynamo?
Yeah,
like,
that's a great question. The way that I like to think about it is like a set of like four, maybe heuristics. Like what makes sense for Dynamo, right? Yeah. If we have something with a lot of where you're already using a lot of GPUs and existing inference engines like VLM or SGLang to serve like a large language model, right? We believe that you can use Dynamo in those situations in order to gain some benefit. And then, disaggregation in Dynamo is another question. Here, I'm going to grab a seat. It's fallen over. It doesn't matter. We're gonna like for disaggregation, there are a set of situations where it really makes sense. The way that I define the situations that makes sense is actually in the negative, right? You probably don't want to use disaggregation in scenarios in which you're generating a ton of output tokens and few input tokens.
Yeah.
Otherwise, a lot of scenarios, depending on the exact model and the exact ISL and OSL, you'll generally get some benefit at fixed latency for applying Dynamo to your existing deployment. And then on the latency throughput frontier side, in the extreme low latency range, disaggregation unfortunately doesn't help much because you're not really driving much throughput in the low latency domain, and therefore disaggregation is not going to help anyways because you're only scheduling one thing at a time. Right. But in everything else, right? In situations that are not like low latency, you're going to see disaggregation and disaggregation through Dynamo drive a lot of performance benefit. So just to summarize, we have the areas in which Dynamo is good are situations in which you have short to medium to even long OSL, and then some, let's say maybe medium to long ISL. And Dynamo is generally applicable to all ISLs and OSLs, to be clear. I'm talking about disaggregation through Dynamo here. And then disaggregation, again, focusing only on disaggregation, not Dynamo as a whole feature set, is generally useful in scenarios where you're in the middle of the throughput latency Pareto curve, when you want to be fast for users or fast for some other reason, but also want to drive low cost. So you don't have to use that many accelerators in order to drive your application.
Yeah, and that's really the sort of majority of use cases, right? You always are going to want to have some kind of balance between latency and cost. You don't necessarily always want to have the most expensive like serving setup because there's like real constraints, right? But also you don't want to have users wait too long. So there's always some sort of trade-off here that you have to make. And Dynamo really helps you like explore that sort of
absolutely
that set of trade-offs and the different setups that you can have to kind of find where you should be on that Pareto frontier.
Yeah, and for those that are like considering applying Dynamo or considering how they want to do something, or in the realm of disaggregation or in the realm of distributed serving, it's always best to start from the perspective of knowing exactly what you want and what you're trying to optimize for. So for some users, we may see that you really want to optimize for cost, but you have a fixed latency that you need to hit, and that's great. We have tools for that, like Dynamo Planner and other tools that allow you to identify the right configuration to hit those targets. And in assessing Dynamo and in assessing any of your distributed LLM applications, it's always best to go in with the knowledge of what you want before you actually start experimenting, right? You usually want to have some fixed target that you want to hit, and then a goal of something you want to optimize while meeting that other constraints. And with knowledge of that, Dynamo is the perfect thing to like actually allow you to pull all those levers and experiment.
Yeah, fantastic. Well, thank you so much, Kyle. Really appreciate the sort of inputs on when Dynamo is useful and when Disag is useful.
To be clear, Dynamo is useful everywhere.
Right. Yes, that's true. Dynamo in particular is useful everywhere when disaggregation is specifically, giving you the most benefit. Okay, this is an interesting question here. Do you have any recommendations to developers who want to work on plugins that add new memory types and transport fabrics to Nixle? For example, Compute Express Link memory devices and fabrics.
Here's a fault right here.
We use CXL to expand host memory capacity and CXL fabrics for high bandwidth, low latency transport layer relative to TCP and RDMA. Well, I have one suggestion that I think is going to be really helpful, was to check out the Dynamo Discord, where we have, I think, like some channels that are specifically about Nixle and about like, or actually, I don't know if we have a Nixle specific channel.
We
but
do.
Yeah, so there were, you can get some more Nixle experts to answer some of your questions.
But maybe a quick summary is like, we have examples of how Nixle is integrated with other backend plugins before. Notably, like we have a plugin for 3FS, which is a file system that was created by DeepSeek. And then on the, like there are other examples of like GPU direct storage file access, and I believe POSIX file access as well. So you can use those plugins as a guide. If you're looking for more explicit information about what is sort of, necessary or advice on how to integrate, you should definitely go and ask us on Discord, because the Nixle team will be there. Hopefully they'll be in another office hours. If people are interested in Nixle, let us know.
Yeah,
we want
definitely.
to know what you're interested in
100%.
and drive different participants in office hours.
Yeah.
We had one more question up there above NVIDIA developer. You may have answered that.
Yeah. How are larger contexts being handled in Dynamo when disaggregated flows require us to focus with smaller contexts?
That's a great question and a little bit more complicated. One of the reasons that I mentioned like small to medium context like favors disaggregation. To be clear, let's separate disaggregation from Dynamo in this context. Dynamo is generally helpful outside of just disaggregation as a concept. But in the case of disaggregation for long context, there are some optimizations that do help and can only be applied in a disaggregated setting. Mm-hmm. One of them is context parallelism. So for example, for Prefill, you can use more GPUs context parallel. That is, they handle different portions of the, completely different portions of the attention, essentially because attention scales quadratically with sequence length. Right. So the thing that's key about disaggregation in that scenario is that decode actually generally doesn't prefer context parallelism, right? It's more memory bound. It doesn't scale quadratically with sequence length per token. You basically want to use disaggregation in that scenario, and I would encourage people to read the Mooncake paper on disaggregation for that includes context parallelism, but allows you to have a different config or different representation of the model on the prefill machines than on the decode machines, which allows you to drive greater performance while meeting SLAs for long context.
Yeah, perfect. Thank you so much. All right, I think we can just about wrap it up. If you have any other questions that you want to ask, please put them in the Discord, and we'll be happy to sort of continue the conversation there. If you want to check out this video later on, it'll be available on the NVIDIA Developer YouTube channel. So you can sort of come back and check out some of the answers that we gave. But yeah, we really appreciate hearing from you. We're going to be doing another office hours again in 2 weeks. So bring your questions if you've got any. And if you have any questions between now and then, again, definitely check out the Discord. We've got a link in the chat. You can always connect with the Dynamo team there.
And remember to reach out to us on Discord or by commenting on the stream on Twitter or LinkedIn to let us know what you'd like to hear us talk about. We can bring in different experts from across the inference ecosystem at NVIDIA to answer your questions about specific integrations, technologies, techniques, or anything else that you may be interested in the realm of distributed inference.
All righty.
Thank you.
Thanks, everyone. Bye-bye.